Today we are going to do the detailed estimation of the pier. So the question is, estimate the quantity of the different items of a pier of an arched culvert up to the springing level for 7.5 meter roadway. In our question, we have this sectional elevation, sectional plan, and this section on AB. So firstly, let's understand what is a pier. Pier is this vertical load-bearing member for transferring the load from the superstructure up to the foundation level. And we have to do the estimation of the pier having the arc culvert. That means these are the piers and this is the arc culvert. So this is the top view of this pier. The cutwater end is the triangular portion of the pier, and the main function of this cutwater end is to offer the less resistance to the flow of the water. And in this top view we can see that this uppermost portion is our cutwater end at the upstream side, and similarly this east water end is the semicircular portion. That means these semicircular portions which is provided at the downstream side to reduce the ET effect of the current. So here we can see that this is the 3D view of this pier, and this is a culvert over this pier. But in our question we have already given that we have to do estimation only up to the springing level. That means this portion is the springing level of this pier. So firstly, let's visualize this sectional elevation that is already given in this question, and in the 3D view it will look like this. This triangular portion is our cutwater end and this semicircular portion is our east water end. And we have this parapet on both sides of this roadway, and we have the roadway of 7.5 meter length. That means this total length is 7.5 meter. So here also we can see that we have this parapet on both sides of this roadway having the length of 7.5 meter from this side up to this side. And here we can see that it is a arc culvert. Now our first step is to calculate this earthwork in excavation in the foundation. And we have this section on AB, and we know that while calculating the excavation height, we have to do the excavation up to the bed level. So we have to do the excavation of this whole portion. And here we can see that we have to do the excavation of this rectangular portion and this small rectangular portion up to the bed level. So since this length and breadth of these two rectangles are different, we are going to do in two different topics. That means we are going to consider this big rectangle as a pier and this small rectangular portion as cutwater end portion. So we have written these two topics, and here we can see that this pier portion is only 1 in number. That means this rectangular portion. So the total length of this rectangular portion is 1.1 meter plus 8.3 meter plus 1 meter. So this total length will be equals to 10.4 meter. And we have only one number of this pier portion, so number equals to 1, and the length equals to 1.1 plus 8.3 plus 1, so we get 10.4 meter. And the width of this pier is from this side up to this side, that is 220 centimeter or 2.2 meter. So I can write the width equals to 2.2 meter, and for the height we have to calculate the total height up to the bed level. So here we can see that this is our bed level portion, and the total height of this excavation will be from this side up this side, that is 45 plus 30 plus 30 plus 30, that is equals to 135 centimeter. So height equals to 1.35, and we get the quantity equals to number into length into breadth into height, that is 30.88 cubic meter. Now our next step is to calculate the excavation for cutwater end. That means we have calculated this portion, that is our 10.4 meter portion. Now this small rectangular portion is remaining, so we have to calculate its length and breadth. So this small rectangular portion is our cutwater end portion having the length of, this is 55 centimeter, okay, this is not 55 meter, so you have to correct it. This is 55 centimeter, so I can write the length equals to 55 centimeter or 0.55 meter. So here we can write the length equals to 0.55 meter, and we have only one number of this cutwater end, and to calculate its width we have to calculate the width from this side up to this side. So here we can see that this width is equals to 160 centimeter, that is 1.6 meter. So we can write that the width equals to 1.6 meter. And to calculate the height, we have to do the excavation up to bed level. So the height is same as this process. So the height will be 1.35 meter. And we get the total quantity 1.99 cubic meter. Now our next step is to calculate the cement concrete in the foundation. So it means that the cement concrete portion is our this portion only. So the length and the breadth will be same, only the height will be different. So the height of this pier is equals to this small portion, that is this dotted portion is our cement concrete portion having the height of 45 centimeter. All the number, length and breadth will be same as this above process. So length equals to 10.4 and the width is also same, that is 2.2 meter, and the height is only different, that is the height equals to this dotted portion, that is 45 centimeter or 0.45 meter. So we get 10.29 cubic meter. Now our next step is to calculate this caught water end portion. That means we are going to calculate this small portion. So we have already calculated its length and the breadth. So only the height will be different and the height is same as this, that is the height is 0.45 meter. So length equals to 0.55. Breadth is also same, that is 1.6, and the height is this dotted portion, that is 45 centimeter. So 0.45 meter, and we get this total 10.68 cubic meter. This cement concrete can also be calculated by this formula, that is 1/3 of the earthwork in the excavation. So we have already calculated this earthwork in excavation 32.87 cubic meter. So we can write that the total volume of this cement concrete is equals to 1/3 into 32.87 cubic meter, that is equals to 10.9. So you can do any of these two process, and this 10.68 is nearly equals to 10.9. Now our next step is to calculate the first class brickwork in the cement mortar. For this we have to calculate this brickwork in cement mortar under three topics, that is one is our pier portion, another is our ease water end, and another is our cut water end portion. That means this rectangular portion at its middle is our pier portion. So we are going to consider this brickwork under the pier portion, and another is our cut water end portion. That means this triangular portion is our cut water end portion, and we are going to calculate this brickwork portion under the cut water end portion, and another is our ease water end portion, because this is our semicircular portion and we are going to consider this portion under the ease water end portion. So first let's calculate this pier portion. So here we can see that this is our first footing, this is our second footing, and this is our third footing, and this portion is our footing up to the springing level, and we are going to do the estimation only up to this springing level portion. So when we observe this first footing from the top view, it will look like this. We have three different portions. This is triangular portion, this is rectangular portion, and this is semicircular portion. So firstly we are going to do the brickwork under this rectangular portion. So the length is from this side up to this side, and to calculate its length we have to see its top view. The length of this first footing is from this side up to this side. That means we have the length of 8.3 meter. So we can write the length equals to 8.3 meter, and we have only one number of footings, so we can write the number equals to 1. So here we can write the number is 1 having the length of 8.3 meter. That means from this side up to this side we have 8.3 meter length, and the width of this brickwork is from this side up to this side. So first let's visualize this section on AB. Here when we cut this pier from this AB portion, that means this is our AB portion, and when we cut this object from this AB portion, then we will get this view. So it means that this portion is 220 centimeter width, and above this the first footing has a width of 180 centimeter, that is this portion, and this second footing is of width of 170, and this third footing is of width of 160, and we can see that this pier is not rectangular, it has two different width. That means this portion is 150 centimeter and above it is 90 centimeter. So this is a tapering portion, so we can write the width is 1.8 meter, that is this portion to this portion. And to calculate the height of this first footing, we have this first footing up to the height of 30 centimeter, so we can write the height is 0.3 meter. So we get the total quantity 4.48 cubic meter. Now our next step is to calculate this second footing. That means from this top view also we can see that this portion is 180 centimeter. But in this figure it is given mistake, that is this total outer to outer portion is 180 centimeter. We have this first footing having the width of 180 centimeter. So this total width is 180 centimeter and the width of the second footing is 170 centimeter. So the total width of the second footing means from this side up to this side we have 170 centimeter, and the width of third footing, that means from this side up to this side, is 160 centimeter, and 150 centimeter width means from this side up to this side. Now our second step is to calculate this second footing of the pier, and we have only one number of this second footing, that means this portion. And when we observe the second footing only, then it will look like this. So here we can clearly see that our pier portion is this rectangular portion. That means now we are going to calculate this brickwork in this rectangular portion only, and this portion is remaining, which we will calculate in separate topic. That means this portion is our cut water end portion and this portion is our ease water end portion. So firstly let's calculate this pier portion. So we have the length of this pier from this side up to this side. That means we have to look in the top view. So here we can see that we are going to do this portion only. So the length of this pier is also 8.3 meter this side. And we have only one number of pier, so we can write the length is 8.3 meter, and we have only one number of this second footing. We have this second footing having the width of 170 centimeter, so the total width of this second footing will be 170 centimeter, and its height is 30 centimeter, that is from this side up to this side. So height equals to 0.3 meter. Now next step is to calculate this third footing, and we need to see the top view. This first portion is our first footing, this portion is our second footing, and this is our third footing top view. So we are going to do the brickwork in this portion. To calculate the length, we need the length from this side up to this side. So the total length will be 8.3 meter, that is same as first footing and second footing. So we can write the length equals to 8.3 meter. So here we can see that the length is 8.3 meter, and we have only one number of this third footing. Now we need to calculate its width. So width equals to, the width of this third footing is 160 centimeter, that is 1.6 meter, and the height is 30 centimeter from this portion up to this portion. So here I have written the width is 1.6 meter and height is 0.3 meter. Now our next step is to calculate this brickwork above the footing up to the springing level. That means we are going to do the brickwork from this portion up to this portion, and to calculate the length we need to see our top view. So this portion is our required portion. That means the total length will be same, that is 8.3 meter from this side up to this side. So we can write the length equals to 8.3 meter. So here the length is 8.3 meter, and we have only one number of this footing. And to calculate the width, we need to see our section on AB. So here we have two different width, that is this portion is our 150 centimeter and this portion is our 90 centimeter. And if we have the two different width, then we need to take the average of these two widths. So we can simply write the average of 150 centimeter and 90 centimeter. That is width equals to 1 by 2 of 1.5 meter plus 0.9 meter. That will be equal to 1.2 meter. So width equals to 1.2 meter. Now we have to calculate the height, and the height is, here we can clearly see it is 360 centimeter. That is 3.6 meter. So 3.6 meter, and we will get 35.86 cubic meter. Now we have done the brickwork in this pier portion. Now we are going to do the brickwork in the ease water end portion. That means our semicircular portion. That means we have already done the brickwork in this rectangular portion for all the footings. Now our next step is to calculate this brickwork for this semicircular portion. So we know that if we multiply the area by the height, then we will get the total volume, and we have the area of the semicircle pi d square by 8. So that means we have to calculate the diameter for each of these semicircles. So when we view this first footing from the top view, it will look like this. That means we have to calculate the diameter from this side up to this side, and we can clearly see that this diameter is equals to this width of this first footing. So the width of this first footing is 180 centimeter from our section on AB. That means the total width of this footing from this side up to this side is 180, and this portion is equals to this portion. That means the diameter. So we get our diameter 1.8 meter. So we can easily write the area of the semicircle equals to pi into diameter square by 8, where diameter equals to 1.8 meter, and we have to multiply the area by its height. So the height equals to, this portion is our first footing having the height of 30 centimeter. So we can write the height equals to 0.3 meter, and we get 0.38 cubic meter. Now our next step is to calculate this second footing, and here also we have to use the same formula, that is pi into d square by 8, and we need to calculate this diameter. So this is our second footing, and we have the second footing in this side also, and it has a width of 170 centimeter. So we can write this second footing is of width of 170 centimeter. So this diameter is equals to 170 centimeter. So we can easily write the diameter equals to 1.7 meter. So pi into 1.7 square by 8, and we have to multiply by its height. So we have the height of second footing is also 30 centimeter. That is, this portion to this portion is 30 centimeter. So height equals to 0.3 meter. And now we have to calculate the area of this third footing and multiply by its height. So to calculate the total area, we need the diameter of the third footing. So here we can see that this portion to this portion is our third footing having the width of 160 centimeter. That means this is our third footing, and we have the width of 160 centimeter. This diameter of third footing is also 160 centimeter. So we can write diameter equals to 1.6 meter. So pi into 1.6 square by 8, and we have to calculate its height. So this is our third footing having the height of 30 centimeter, that is 0.3 meter. So we get 0.3 cubic meter. And next is our footing up to the springing level. That means this portion is our footing up to our springing level. So here we can see that this portion is tapering. So here we can see that this portion has larger diameter and this portion has a smaller diameter. So if we have two different diameter, we need to take the average of the two. So we can easily write the diameter equals to average of 150 centimeter. That means this portion, and above portion is 90 centimeter. That is this portion. So we can write the diameter equals to average of 1.5 meter and 0.9 meter. That is equals to 1.2 meter. So we can write pi into 1.2 square by 8. And we have to multiply by its height. And we have the height of 360 centimeter. That is 3.6 meter. So we get 2.04 cubic meter. Now our next step is to calculate this cut water end portion. That means our triangular portion. So here we can see that this is our first footing and this is our cut water end portion, and we know that the formula for the area of the triangle equals to 1 by 2 into base into height, in which the base is our this portion and height is our this portion. We have already calculated this base, but we don't have this height, so we need to calculate its height. And one thing you need to know is this cut angle are at the angle of 60 degree. That means this total angle will be equals to 60 degree, and we can use the Pythagoras theorem to calculate this total height. So since this is 60 degree, this small angle will be obviously 30 degree, that is 60 by 2. And we know that this portion is our 180 centimeter that we have already calculated from our section on AB. So since this is our midpoint, we can write that this small portion is 180 by 2, that is 90 centimeter from this side and 90 centimeter from this side. So it means that we are going to see this small triangle, that is this blue color triangle, and we have this angle 90 degree, and we are going to find this base. So we can use the trigonometric relation of this base and perpendicular. That means we can use the formula for tan theta, in which theta is equals to 30 degree. So we can use that tan 30 degree equals to perpendicular by base, in which our perpendicular height is 90 centimeter. So I have put this value 90, and we have to calculate this base, so it is unknown. So while equating this, we get b equals to 90 by tan 30. So we get the value of the base 155.88 centimeter. That means this portion is 155.88. So we have this cut water end 1 in number, and we have the area of the triangle 1 by 2 into base into height, in which base is this portion, that is 180 centimeter or 1.8 meter, and the height of this triangle is from this side up to this side, that is we get 155.88 centimeter, or in terms of meter we can write 1.56 meter. So 1.56 meter, and the height of this cut water end portion is, this portion is 30 centimeter height, so we can write the height equals to 0.3 meter. So here we can write 0.3 meter, and we get 0.42 cubic meter, because we know that the volume equals to area into height. And now we are going to calculate this second footing, and here also we can use the same formula, that is area of the triangle equals to 1 by 2 into base into height. That means we have already calculated the brickwork in these two portions, and now we are going to do this small portion for the second footing. So for this we have to calculate the total area of the triangle. So the area of the triangle equals to 1 by 2 into base is this portion and the height is this portion, but we don't have this height, and we are going to calculate this height. And we have this angle 30 degree from this side, and here also 30 degree from this side. So we can use the simple formula for the trigonometric relation, and we know that the width of this second footing is 170 centimeter from our section on AB. So we have this portion, that is the width of this footing is 170 centimeter, and this is our midpoint. So the total width at its half of its end is 170 by 2, that is 85 from this side, and here also 170 by 2, that is 85 from this side. And we are going to calculate this B, that is base portion, and we have the angle 30 degree. So we can use the relation of tan theta, in which theta equals to 30 degree. So here I have written that tan 30 equals to perpendicular by base, in which our perpendicular height is this portion, which is 85 centimeter, and our base is unknown, so I'll write it as B. So we get the value of the B equals to 85 by tan 30. While calculating this value, we get B equals to 147.22 centimeter or 1.47 meter. So we have the area of the triangle equals to 1 by 2 base, in which our base equals to 170 centimeter, and height, that means this will be the height of the triangle. So the height of triangle equals to 1.47 meter. So I can write the base is 170 centimeter or 1.7 meter, and the height is this portion, that is 1.47 meter. So here 1.47 meter, and we have already calculated this area, and we have to multiply by its height. So height equals to height of the second footing, that is 30 centimeter, that is 0.3 meter. So we get 0.37 cubic meter. Now our third step is to calculate the third footing of the cut water end. Here also we need to use the same formula, that is area of the triangle equals to 1 by 2 into base into height, but our height of the triangle is unknown, and we need to find this height of the triangle by using this tan theta relation. And we have the width of this third footing 160 centimeter. That means here we can see this is our first footing, this is our second footing, and this is our third footing, having the width of 160 centimeter, that is this portion. And now we have already calculated the brickwork in this semicircular portion and this rectangular portion. Only part remaining is this triangular portion. So we need to find the area, and before finding the area we need to calculate the height of this triangle, that is this portion. And we have already said that this angle is 30 degree, and here also 30 degree, and we have this 90 degree. So this portion is also 80 centimeter, and this portion is also 80 centimeter, that is 160 by 2. So here we can use the trigonometric relation of tan, and tan 30 equals to perpendicular by base, in which our perpendicular height is 80 centimeter and the value of this base is unknown. So we are going to calculate this value of this base. So we get B equals to 80 by tan 30. And while equating this, we get the value of the base equals to 138.56 centimeter or 1.38 meter. So we have one number of this third footing, and the area of the triangle equals to 1 by 2 into base, in which our base is this total portion, that is 160 centimeter, or we can write 1.6 meter, and height of this triangle is equals to this portion, that is we have obtained 1.38 meter. So we can write 1.38, and we have calculated this area and we need to multiply by its height. So the height of this third footing is equals to 30 centimeter from this section on AB. So we can write the height equals to 0.3 meter and we get 0.33 cubic meter. Now our next step is to calculate the above footing up to springing level, that means this triangular portion of the pier. So here we can clearly see we have the bigger triangle at the bottom of this pier, and here is our smaller triangle at its top. Since we have two different triangles, we can use the average area for these two triangles. So here we need to first calculate the average width of this tapering portion. That means this portion is 150 centimeter, upper portion is 90 centimeter. So we need to take the average of these two. That means we get 120 centimeter. So we need to calculate the area for this tapering portion at its midpoint. So this is our mid portion of this pier, and we are going to calculate the area of the triangle at its middle portion, so that we can get the average value of this area. So here we have this middle portion 120 centimeter, and we are going to find this height of this triangle. So we can use that tan 30 equals to perpendicular by base, in which our perpendicular height is 60 centimeter, and we are going to find this unknown value of this B. So we get this B equals to 60 by tan 30. So we get B equals to 103.92 centimeter, that is 1.04 meter. So we have one number of this footing. So I can write the area of the triangle equals to 1 by 2 into base into height, in which our base is this portion, that is 1.2 meter. So 1.2, and the height of the triangle is equals to this portion, that is 1.04 meter. So 1.04 meter. So we have this height of 360 centimeter. So we can write the height equals to 3.6 meter, and we will get the total quantity 2.25 cubic meter. Our next step is to calculate the estimation of the cement concrete at the upper part of the ends of the pier. That means here we can see that above the springing level we have this small quarter of this sphere portion at this side of the pier. So at the east water end we need to do the cement concrete on this side. We have to use the formula for the volume of the sphere and divided it by 4 to get the quarter of the sphere. So we already know that the volume of the sphere equals to 4 by 3 pi r cube, but we need to calculate the radius. That means this radius will be this total width by 2, that is the small portion would be 90 centimeter by 2. So we can say that the radius equals to 90 by 2, and we have the volume of the quarter of the sphere equals to 4 by 3 pi into r cube, where r is the radius, and since it is a quarter of the sphere we have to divide it by 4. So we can write that the radius equals to 0.9 by 2, since the total diameter equals to 90 centimeter and the radius would be 90 by 2. So we can write that the radius equals to 0.9 by 2, and we have to put the value in this formula. So we have 4 by 3 into pi into r, that is 0.9 by 2, and then cube of the radius, and we have to multiply it by 1 by 4. So we have already calculated the volume of this portion. Next is our cutwater end portion. That means in this cutwater end portion we can see there is a triangular pyramid portion. So we can use the direct formula of this triangular pyramid, that is volume of this triangular pyramid equals to 1 by 3 into area of the base triangle into height. So firstly we need to calculate the area of the base triangle. So here this is the cut end portion, and we need to calculate the base area, that means this portion, and we should multiply by the height. So firstly we need to calculate the area of this base triangle, and we have the area of the triangle 1 by 2, and base is this portion, and height will be this height of the triangle. Width of the pier is 90 centimeter at its top portion, and this portion is 45 that is 90 by 2, and this portion is also 45, that is 90 by 2, since this is the midpoint. And we have this angle 90 degree. We can use the trigonometric relationship of tan to find this length. So we can write tan 30 equals to P by B, in which our perpendicular height is this portion, that is 45 centimeter, and this portion is unknown portion. So we can write as it is, that is B. So we will get the B equals to 45 by tan 30. So we can get the value of the B equals to 77.9 centimeter, or in terms of meter, we get 0.779 meter. Now we can easily use the formula for the area of the triangle. So we have the area of the triangle equals to 1 by 2 base into height, in which our base of the triangle is this total base. So this base equals to 90 centimeter or 0.9 meter, and the height of the triangle is this portion, that is 0.779 meter. So height equals to 0.779 meter, and we get 0.35 meter. So now we have to put the value of this area of the base in this formula. So here we have this total width of this pier 90 centimeter. That means the diameter equals to 90 centimeter, and this portion is the radius. So radius equals to 90 by 2 or 0.9 by 2 meter, and we know that the radius are equal. So this portion is also the radius, and this height is also the radius. So we can easily write the height equals to 0.9 meter by 2. So the height equals to 0.9 by 2. So I can write the volume equals to 1 by 3 into area of the base equals to 0.35. So here 0.35, and the height is 0.9 by 2. So we will obtain 0.052 cubic meter. Now our last step is the cement pointing in the exposed surface. That means we are going to do the cement pointing on all these sides and this side. We will consider them into three topics, that is, this is our rectangular portion, and we will consider it as our pier portion, and this is our triangular portion. So we will do this cement pointing as our cut water end portion here, and this is our semicircular portion, so we will do it as the ease water end portion. So first we will do this pier, that is the rectangular portion. So we have to do this cement pointing on this side of the pier as well as on this side of the pier. That means we have two number of this rectangular surfaces. So we can write the number equals to 2. So here we can see that this rectangular portion is of the length of 8.3 meters. So it means that this rectangular portion is of 8.3 meter length. So the total height of this pier equals to 3.6 meters. So I can write the height equals to 3.6 meter. And we know that this cement concrete is calculated in meter square. So this length into height is equals to 59.76 meter square. Now the next is our ease water end portion, which is a semicircular portion. That means we are going to do the pointing on this side, that is this semicircular portion. But here we can see that we have two different diameter, that is this upper portion has a diameter of 90 centimeter and the lower portion has a diameter of 150 centimeter. So I have already told you that if we have two different diameters, then we need to take the average of these two. So we have to take the diameter as average of 90 centimeter and the 150 centimeter. That would be 120 centimeter. So firstly we need to find the perimeter of semicircle, and we have the perimeter of circle pi d. So obviously the perimeter of semicircle equals to pi d by 2. Diameter equals to average of these two width. So diameter at center equals to 90 plus 150 by 2. That will be 1.2 meter. So we have the total area of this ease water end as pi into 1.2 by 2, and the height of this cut water end portion is 3.6 meter. So I can write the height equals to 3.6 meter. And lastly our cut water end portion, that means we have this triangular portion on this side, that means this total portion, and on this side. So obviously we have this two number of this cut water end portion. So now we are going to do the pointing on this side and back side. So for this we need to calculate the incline length at its center, since we have two different incline length at top and bottom. So to calculate this incline length we need to use the trigonometric relationship of sine, because we have this total width of 120. So here we have this width at its midpoint 1.2 meter, that is the average of 150 centimeter and 90 centimeter, and we have this angle 30 degree, and we know that this length is equals to 1.2 by 2, that is 0.6 meters. Since this is a midpoint, we have to find this length, that is this inclined portion length. So we have sine 30 equals to P by H, in which our perpendicular length is 0.6, and we have to calculate this hypotenuse. So we will get this hypotenuse 1.2 meter, that is this portion, that is our inclined length is 1.2 meter. So we can write that the pointing equals to this inclined length 1.2, and the height is obviously 3.6 meter, because we have to do the pointing all over this height, that is 3.6 meter. So we get 8.64 meter square, and we have this two number of cut water end, that is one on this side and another on this side. In this way we get two number of this cut water end. So in this way we have completed the detailed estimation of a pier. And if you like the video, please like, share and subscribe.